Welcome to Tech Vidya Dan.
Hello viewers, welcome to my channel Tech Vidya Dan. Today I will discuss multiple input, multiple output of wireless communication. This multiple input and multiple output is known as Mimo technology. This lecture is totally conducted by me, that means Professor Orithro De. So these are my contents for today. First we will discuss SISO, that means single input, single output. After that I will discuss SIMO, that means single input, multiple output. Next I will discuss MISO, that means multiple input, single output. And lastly I will discuss multiple input and multiple output or MIMO. Next I will discuss orthogonal frequency division multiplexing or OFDM. After that I will discuss NOMA. What is the NOMA? NOMA is non-orthogonal multiple access. And lastly there will be my references. So let us start our basic discussion for today. First I will discuss single input, single output. In single input, single output, there is one single antenna at the transmitter and a single antenna at the receiver. That means signal is transmitted from the transmitter and received at the receiver. But what happens if the transmitted signal is corrupted? In that case, you can't receive any information or signal. In that case, you have to modify this block diagram or this technology. Then we introduce single input, multiple output block diagram. In this case, there is one single antenna at the transmitter and the multiple antennas at the receiver. So if one copy is corrupted, then other copy will receive properly. So you can retrieve the signal properly. This is known as single input, multiple output. But what happens if the transmitted signal is corrupted? In that case, the total signal can't be received at the receiver. So we have to modify this technology. Then we introduce MISO. What is a MISO? MISO is multiple input, single output. That means there are multiple number of the antennas at the transmitter and the single antenna at the receiver. That means you are transmitting multiple number of the signal from the transmitter side, and at the receiver there is one single antenna. What happens if the signal is corrupted at the receiver? Then also you can't receive the signal properly. So you have to modify this technology and you have to introduce multiple input, multiple output. In this case, multiple number of the transmitter is used at the transmitter and the multiple number of the antennas are used at the receiver. So in this case, the reliability of the signal is enhanced, as there are multiple number of the transmitted antennas or multiple copies of the transmitted signals from the transmitter to the receiver. Here the data rate also enhanced and the capacity of the system is also improved. Now there is another technology of this MIMO which is known as massive MIMO. In massive MIMO, there are huge number of the antennas are used at the transmitter and the huge number of the antennas are used at the receiver. This massive MIMO uses a emerging technology from the third generation, fourth generation wireless communication onwards. It is used almost everywhere in fifth generation wireless communication. Now what are the MIMO application? Obviously MIMO is used in the wireless communication. Hence the wireless communication performance is improved. This is a cost effective way to improve the spectral efficiency. As you have to improve the spectral efficiency, you can introduce multiple number of the techniques like game theory and the optimization to improve such spectral efficiency. This is a challenge for the engineers or the researcher of the modern era. Now we will discuss orthogonal frequency division multiplexing. Here we are considering two users, user 1 and the user 2. User 1 are using this blue set of the frequencies and user 2 are using this black set of the frequencies. You see, the frequencies are perpendicular to each other. If the frequencies are perpendicular to each other, that means angle theta is equal to 90 degree. And what you know from the concept of the vector algebra, that the overlap from one signal to the another is cos 90 degree. Now if this cos 90 is 0, that means there is no overlap. That is the advantage of orthogonal frequency division multiplexing. But what happens if the number of the user will increase more? A massive number of the user we have to allocate. In that case, we will use NOMA, which is non-orthogonal multiple access. You see, in this case, user 1, that means blue set of the frequencies, and user 2, that means black set of the frequencies, are overlap with each other. So you have to control the power so that this interference or overlap can be minimized. This is also a major challenge for the modern generation wireless engineers or the researchers. Very much interesting, isn't it? Let's go. So what we have discussed today? We discussed Mimo basic concept. After that, we discussed non-orthogonal multiple access only introduction part. So these are my references. Lastly, thank you for watching my video. If you have any doubt, you can email me at auditro.btech.electronics or at deauditro2001@yahoo.co.in. You can WhatsApp me your doubts at my mobile 94331 96353. That's all for today. Stay tuned to Ganon, stay safe, stay healthy. Thank you viewers, bye.